Okay, now let's talk about isotopes. By definition, an isotope is two versions of the same element having different numbers of neutrons. Two versions, same atom, having different numbers of neutrons. So when I think about this, I think of a couple of them. And I think of hydrogen 1 and hydrogen 2 and hydrogen 3, right? They have a name. They have number 2 is called deuterium, and number 3 is called tritium. So we have hydrogen 1 versus hydrogen 2. Now, why am I using this form? I don't know. It's just the form that I'm choosing to use hyphen notation. I could have written it, hydrogen 1 over 1, or I could have written it hydrogen 2 over 1, where 2 is the mass number, this is the atomic number. Mass number, atomic number. First thing I have to do here is I have to figure out protons, neutrons, and electrons. Well, the atomic number is 1. You can get that right from the periodic table. So it applies to both of them. Therefore, 1 proton. Notice, 1 proton. There's no charges here. I don't have, plus 1 or plus 1 here. So therefore, 1 electron, 1 electron. They're not charged. They are not what we call ions. We'll get to that eventually when we charge them up. So, mass number of 1, atomic number of 1. 1 minus 1 is 0 neutrons. Here, what you end up with is 2 minus 1, so this is 1 neutron. And this is the precursor for a hydrogen bond. So what you would do here now is this. 1 proton, 1 proton, 1 electron, 1 electron. What I would do is I would make one drawing if I wanted you to for these isotopes. If I said draw both isotopes, here's what I would draw. I would draw a nucleus. I put 1 proton inside the nucleus. Then I would do this. I would say 1/2 neutrons. What does that imply? Sometimes it's 1 if it's hydrogen 1. Sometimes it's 2 if it's hydrogen 2. Electrons. We know that the Bohr model contains at most 2 electrons in the first energy subshell. And so this only needs 1 electron. So we place 1 electron, and that is the diagram for 2 isotopes of hydrogen. Again, 2 versions, same element hydrogen, having different numbers of neutrons. And that's how you would depict it, 1/2 neutrons. Why draw 2 drawings?